Welcome friends to my YouTube channel. Now on my last lecture I have discussed about the Poiseuille's equation. Okay, that is the flow of viscous liquid through a horizontal narrow tube. Okay, and we have find that the volume of the liquid flowing out per second through the tube of radius r and length l and having the pressure difference P at two ends is this. Okay, so V is the volume of the liquid or flowing out per second or the rate of flow. R is the radius of the tube, L is the length of the tube, P is the pressure difference between the two ends of the tube, and eta is the viscosity coefficient. Now, while deriving the equation, I have mentioned that the liquid flows in streamline motion. Okay, that means the magnitude and direction of velocity at every point remains constant. Okay, so if velocity is uniform, then acceleration must be zero. But in actual practice, this does not happen. That means the liquid has some acceleration at the inlet end of the cylinder. Okay, so since there is a acceleration at the inlet end of the cylinder, so this equation needs a modification. That means we have to make a correction to this. Okay, so the first correction is due to acceleration correction. Okay, acceleration correction. Okay, so in actual life or in practicality, I have told that there is some acceleration of the inlet end of the tube. Okay, so in order to make correction due to acceleration, we have to increase the length of the tube by some factor. What? Though liquid flows in streamline motion, there is some acceleration at the inlet end of the cylindrical tube. Okay, so surely it will impact the equation. So in order to make correction, what we have to do? So we have to increase the length of the tube by a factor 1.64r. So previously the length is L. So what will be the actual length? So what would be our actual length? The initial length is L, and we have to increase this length by a factor. This is the actual length. So instead of L, we have to put L plus 1.64r. That means 1.64 times the radius. Okay, so this is the acceleration correction. Okay, so this is the acceleration correction. So this is the acceleration correction. Now another is kinetic energy correction. Another is kinetic energy correction. What is this? Now we all know that the viscous force acts in the opposite direction of the flow of liquid. So a portion of the total energy is used by the liquid to overcome the viscous force, and the rest will convert it into the kinetic energy. Okay, so the total energy can be divided into two portions. One part is used to overcome the viscous force, and rest is converted to kinetic energy. Rest is converted to kinetic energy. Okay, rest is converted to kinetic energy. Okay, fine. Now suppose if P dash be the effective pressure that overcomes the viscous force. Okay, so what would be the energy required to overcome the viscosity? That is P dash V. Okay, if PV be the total energy, okay, because P is the pressure difference between the two ends of the tube, so this is the total energy, okay, or work. And if P dash is the effective pressure that overcomes viscous force, so this is the energy required to overcome the viscous force, and rest is converted to kinetic energy. So we have to calculate this. Okay, so we have to calculate this. Okay, so what would be the kinetic energy of the liquid? That we have to calculate. So the kinetic energy of the liquid will be half mv square within 0 to r. What is m? That means density into volume. The density is rho, and what is volume? Area into velocity. That means area of the elementary annular zone between the cylinders of radius x and x plus dx. That is 2 pi x dx. Area into velocity. So this is m. Okay, and this is v square. Okay, half mv square. M means rho into v. V means elementary area multiplied by velocity. So this is okay. So 2 cancel. So pi rho is this. So this is simply v cube x dx. And we know the expression of v, that is the velocity of any layer at a distance x from the axis of the tube, p by 4 eta l into r square minus x square. So v is a function of x. X is involved here, so we have to put the value of v in this equation. So what we get? Pi rho 0 to r x into r square minus x square whole cube dx. Pi rho p by 4 eta l whole cube 0 to r x into this r to the power 6 minus 3r to the power 4x square plus 3r square x to the power 4 minus x to the power 6 dx. Okay, so this is the kinetic energy. So pi rho, this is simply p by 4 eta l whole cube, and if we do it, the result will be r to the power 8 by 8. Okay, so and if we rearrange this, we can write v cube rho by pi square r to the power 4, where we use v, this is pi p r to the power 4 by 8 eta. Okay, now this is the total energy, and if P dash be the effective pressure that overcomes viscous force, so this plus kinetic energy, this. So from which we can write P dash, this equals to P minus V square rho by pi square r to the power 4. So there we see, instead of P we have to substitute P minus V square rho by pi square r to the power 4. Okay, now if we combine these two corrections, that is length correction and kinetic energy correction, then what would be the equation? Pi P, and instead of P we can write P minus V square rho by pi square r to the power 4 into r to the power 4 8 eta L, that means L plus 1.64 r. So this is the modified form of Poiseuille's equation. Okay, so due to acceleration there is a correction, and due to kinetic energy there is a correction. Okay, and a part of the total energy is used to overcome the viscosity and the rest is converted to kinetic energy. Okay, so by combining these two corrections we have obtained the modified form. Okay, so if you don't subscribe my channel, then kindly subscribe it to get latest videos on physics. Okay, today is up to this. Thank you.